So hello, everybody. My name is Clemens, and I'm working as a platform engineer at Humanitec. And in this capacity, I'll tour you around the whole estate of infrastructure platform engineering today. I'm originating from Hilden, which is a little town in Germany, almost in the geographical center, funny enough. And it's close to Düsseldorf, which is a bigger city, and that is close to Cologne. And everybody knows Cologne because there's that church standing around there, right? So that's where I'm living with my three kids, one wife, one dog, and yeah, a lot of fun here. So, um, are we sharing the recording via VJet? For sure, we will. The session is being recorded, and we are also going to post that on YouTube as soon as all of the post-processing is done. All right. Yeah, speaking of the devil, as it is being recorded, if you do not want to be recorded, you literally have to drop out because we cannot stop that. It's live on YouTube. All right, I see a few people coming out of Düsseldorf. That's awesome. Literally, hit me up on LinkedIn or hit me up on platformengineering.org in the Slack. I am at J over there. Just hit me up and we might even go for a coffee sometime. Right? Awesome. All right, so infrastructure platform engineering. Wait a second. As usually, I'm sufficiently surprised that I need to share anything, and I'm a confessing desktop messy. So give me 2 seconds while I try to share the stuff that I want to show you. And also, I need to get you over to my second monitor. Not that I see too many things like turned on cameras. Right now, it's only Maria and me, I think. But apart from that, yeah, waving or even shouting won't work this time. So if you have anything that needs immediate fixing, please put it in the chat. And I hope that Maria will poke me because I'm not looking at the chat all of the time. If it has a little bit more time, please put it into the Q&A tool, and I will try to periodically look in there. Yeah, as I said, platformengineering.org. You can find me there as @J in the Slack or clemens@humanitec.com. Shoot me a line. I'm usually happy to respond and have great discussions. So let's get going. What we want to see today, or the things we'll touch today, rough agenda is we're going to have a short intro, obviously. Then we'll look into the 5-minute IDP. And I hope you all got the preparation mails that you need to have your Humanitec demo account, and that you need to have a few things like humctl installed and working, and the Docker daemon, because you can see the symbols. This is really going to be hands-on. So I will be showing stuff, and if you have all of the prerequisites in place, it should be easy for you to follow along. Yeah. If you're already in platform engineering chat, then it is also easy to go into the right channel. Speaking of the devil, the right channel, do you remember the name, Maria? What was the name?
I don't remember, but let me quickly take a look.
Yeah, it's going to appear in the chat sometime soon. The name of the right channel and platform engineering Slack, and I will most probably be posting things there, because if I put it into the chat in the webinar, it's most of the time going to not end well if you copy paste that into your terminal. So it's going into Slack. Right, so 5-minute IDP, first session. Hopefully it's going to be 5 minutes. We'll find out. Your own first IDP, quicker than a bowl of ramen. That's the idea. Then we'll touch base on infrastructure platform engineering, take a look at all of the best practices that I can summon from my own frame of reference. And then we'll take a look at 2 more demo cases. One will be DB as a service, which will basically demonstrate how you would integrate something as a service that is probably provided by one of your infrastructure and operations teams as a service into your IDP. And by that, basically fuse the 2 domains of platform engineering and infrastructure platform engineering. And then we'll do the same for observability to shine light on a cross-cutting concern. And if that all goes well, we'll wrap it up and hopefully have some good answers to interesting questions. Cool. That's the menu for today. And yeah, housekeeping. I'm aiming to have a 5-minute break every 30 minutes. So let's see. Timer. Okay. Yeah, let's start that now and see. Right. So I'm aiming to have that break because nobody should be trying to die in front of the monitor. We all need a little bit of time to catch a fresh coffee or have a bio break. The prerequisites for the hands-on parts, yeah, if you don't have them, you cannot run the hands-on parts, obviously. Join Slack now. As I already said, I will copy and paste all the things in there for you. And questions, Q&A tool for the things that can wait. So Maria, did you dig up the name of the right Slack channel?
Yeah, I just posted it in the chat. The name is #workshop infrastructure platform engineering. You guys, you can just click the link first to join Slack, Platform Engineering Slack, and then just type in this channel in the search bar and join it. I think it's open for everyone to join.
Yes, it should be. If you're on the right Slack, mind you. Workshop infrastructure platform engineering. That's the one. Okay. If you can read me saying hello webinar, then you're on the right channel. Right. And if you need to join Slack, upper right-hand corner, the QR code will also get you there, or the link displayed here. Okie dokes. Right. So let's quickly get on the same page. Who we are and why we do this. And who we are is, in this case, Humanitec, the company that I'm working for, which is dabbling mainly in platform engineering. All right. So Humanitec, we serve platform engineers with a build and blend approach. What does that mean? That means if you're building out an internal developer platform, the I or the internal basically means that this is something custom built for your requirements and your company. You cannot acquire that on the market, right? You need to build that. And you can obviously build the whole thing, but you don't need to. Right? You can also acquire best practice components from the market and blend them into what you're building. And this is exactly what we offer. We offer best practice or best in class components. One of them being our orchestrator, which is a graph-based platform backend. We offer a portal front end that is accompanying the orchestrator. And we also have Score. And Score is, as of last week, finally a project in the CNCF sandbox, which we are mighty proud of because we are finally getting rid of it. No, all jokes aside, we are we are as much involved in Score as we have been, but it's great to see that it's now under stewardship of the CNCF. So we've all seen what happens when licenses suddenly change because of acquisitions and movements, and we didn't want to see that happen to Score. We think this is so great, it needs to be free forever and available to the community, and that's now happening. Right. Marketing wants me to talk a lot more about the processes, how we actually make someone get from nowhere, literally where you are now, to be on top of your first IDP or of your first MVP, minimum viable platform. Let's not talk about that too much, right? Let's keep the marketing topics for later if we have a lot of time left, and rather dive into the content. Right. So, bird's eye perspective. How does this work? Essentially, what we are trying to build out today is an IDP. And in the smallest sense, you have a developer, right, which is basically first-class citizen of your ecosystem, being a customer, which defines a workload, so the thing he's building, and the resource dependencies with the Score workload specification. Resource dependencies are anything that this workload actually needs to have inside of the runtime environment to be able to fulfill its destiny. That could, for example, be a database or a message broker, a Kafka queue, or whatnot, right? Could be anything. And this ask here should be as abstract as possible. But to get from an abstract ask to a specific implementation, you need somebody who fills in the details. And obviously, that's the platform engineer down here. He defines how resources are provisioned with resource definitions and criteria specifying where they apply. That means I can, depending on the context, make the robot, the platform orchestrator here, do different things. The outcome will always be the same. The application configs will be created, the infrastructure will be matched or created, and the workloads will be deployed. Yeah, which in the end leads to a running, fully configured application. But depending on the context, and that could be local, development, staging, production, sandbox, toys, I don't know. Yeah, whatever you have inside of your company, how the things are named, it's always from the orchestrator's perspective, a different context. And infrastructure might be different in a different context, right? That's how it works. So let's take a look at how the magic happens from the technical side. So SCORE is an abstract format for developer self-service. What are the important parts of this YAML-based specification? The ones in red, obviously, right? So we are looking at a product service here, and the developer wants to have some resources so that his product service can work. That would be a PostgreSDB, an S3 bucket, and a DNS record, because who likes typing IP addresses, right? The routing, the connection string to get that Postgres connected, right? You can see there are replacers here, which basically say, hey, take from the resources, right? Resource DB over here, that Postgres, and put the username in here. And then you follow along to create a Postgres connection string. Yeah. And that means what you see here is completely environment agnostic. That's the promise of SCORE. You only need one. It's equally useful if you deploy that stuff on top of your local Docker daemon, or if you deploy it via the orchestrator to the cloud or to anywhere else. Because the infrastructure, the Postgres database, will be created. Then those replacers will be replaced with the actual data. Because of that, your application can read the dbcon variable from the environment, configure itself to run with the correct database, and everything will be good. And what you can also see, it's platform agnostic. I've said that a few times, right? Could be Docker locally, like Docker Compose, could be something in the cloud via the orchestrator, could be something completely different. It's a CNCF project. You can write your own implementations, how this specification gets translated into the platform-specific language. And by that, adopt it to any platform out there. Right. So if the developer doesn't specify the specifics, well, the platform engineer has to. And this is a resource definition. That's how infrastructure and operations teams, which probably are heading on or spearheading the platforming approach, are actually defining the rules. So once again, it's YAML-based specification in this case, and we are looking at resource definition of type Redis. It is using the Terraform driver, so that means there needs to be a Terraform module somewhere around here. And sure it is here under revision control in GitHub. And we're using exactly this revision here and nothing else to create the Redis cache that we so much desire. Or in this case, we can read from the name, it's probably going to be an Elasticache cluster on top of Amazon. All right? And when is this being used? Well, if the environment type is staging. In staging, using a cloud service probably might make sense already. In development, sometimes yes, sometimes not so much. Probably you just want to start a Redis container, which is open source. It doesn't cost you a thing. It is cheap, it is fast, and nobody cares if it dies, right? Because it takes probably a few milliseconds to start it again. All right. So let's take a look at what we will see happening in the 5-minute IDP very soon. The orchestrator will create a resource graph from SCORE and the resource definitions. So that means the INO people have created this set of resource definitions, which configure the orchestrator to respond to this ask by the developer. And in this case, he wants to have a Postgres DB and an S3 bucket. Yeah. So CI picks up that notion, projects it towards the orchestrator, and conveys the context. How does that happen? Usually you have different pipelines triggered by the actions of the developer, right? If I just push some code, this will end up on top of my development system. If I put a tag on a certain point in code, demarcating this as my next release candidate, well, I probably want this to be progressing to staging. Yeah, and this is happening in this case. So the context is staging, the platform orchestrator knows and can pick up the right stuff for context staging. Right? And that leads to the fact that the resource graph is being created. Why does that make a lot of sense? Well, infrastructure is a graph problem. It's not a pipeline problem or a linear problem. It's a graph problem. Why? Well, these things have relationships. Yeah? This product service depends on these resources, and now we do not have a complicated relationship, but just envision the relationship of that DNS record. The DNS record on itself doesn't do anything. There needs to be a relationship to an ingress, right? And that ingress is needing the right configuration. So it's probably relying on a TLS certificate to have a secure connection, which is in turn relying on the DNS record. Why? Well, because it needs to match to the domain name, which is specified in there. Right? So what we are creating here is an acyclic dependency graph. And acyclic directed dependency graphs have the nice property that you can simply sort them in topological order and then linearly execute them. Yeah, there are no circles, so there is no branching logic needed, and topological sorting them will always result in a linear execution pipeline. And that is exactly the reason why all infrastructure management tools out there, all infrastructure as code tools like Terraform, like CDK, like whatnot, all object-based systems like Kubernetes itself, for example. Well, object-based in this case is just a fancy words for being graph-based again. Yeah? They are all relying on graphs for that simple reason. It's just a graph problem. Yeah? That's the reason why we're doing this here as well. But we are elevating the graph problem one level higher to include the application. All right, so now next release comes around. Developer has the idea, like we've seen on the last slide, that a Redis cache would be great to have around. All right, so what happens next is goes through CI again. Orchestrator looks up, okay, where's the right resource definition? And then according to that resource definition, creates the new graph. The graph once again gets sorted and gets executed. Funny enough is that we can also diff graphs very easily. And because of that, we do not need to execute everything again. We can simply rely on the fact that everything else should probably be okay. And we can just create the Redis cache and update the configuration of the product service. And we are good. So this is what's happening behind the scenes inside of the IDP. Right. Let's take a look at how the architecture of the 5-minute IDP is actually looking, and then we'll run the setup process for that. So that architecture is literally pretty simple, right? You start out with the cloud and your computer. On top of your computer, there's a Docker daemon. On top of the cloud, we are running the Humanitec orchestrator as a SaaS service. What then happens is that we will run a kind cluster. So we finally have Kubernetes on top of your local Docker daemon as a sandbox environment. Well, the problem is if you now want to create a deployment from the cloud on top of your machine, you're usually running into a firewall. Because there is no network connectivity, there's no routing into the private IP zone that your local hardware will be running in. How to avoid this problem? It's pretty simple. On top of the Docker daemon, we will run a so-called agent. And that agent is going to open up a secure TLS tunnel to the orchestrator. So we are drilling a way to reach the orchestrator from the inside of the Kubernetes cluster. And then we'll let the orchestrator communicate through that tunnel with the cluster. And by that, we solve the problem. And we enable the SaaS orchestrator to deploy to your local notebook. or desktop machine, whatever it is. Compute box. All right. So this is the place where you probably want to be now. QR code is now a different one. It will actually open the 5-minute IDP tutorial. You could also use this tiny URL here, or type in the long one if you fancy it. I might even put that into the chat. No, I will put that into the chat. Let me do that. Once again, chat in this case being in platformengineering.org, B channel workshop infrastructure platform engineering, all separated by dashes. All right, and as you can see, this is literally the tutorial I have already opened here. It is the 5-minute IDP tutorial. You can see Johannes here. That's the colleague who created the first version. This time I don't have it around. I'm running this workshop for the second time. During the first iteration, it was so much fun because he was actually driving in the background and helped people who had any kind of technical problem. Yeah, sadly, we don't have him around this time, but at least we can enjoy his image over here. All right, so let's check first, right? For me, there's no magic allowed. I'm not allowed to cheat because you need to be able to follow along, right? So let's take a look. So this is my Docker desktop dashboard. There's nothing in here, no containers running. I can verify that on the terminal as well. Do Docker ps-a. Nope, nothing. That's how it should be. This is it, no cheating allowed for me. So, and I'm going to follow this tutorial. So now I'm going to copy paste from here into my terminal, humctl login. So this is literally to authenticate my CLI. Will tell me, all right, this is my account name. This is the device code. You can see city of Hilden. I have not been lying in the first place. And I want to authorize humctl. Okay, now my CLI is authenticated for the next 24 hours. And as you can see, it tells me I should unset the Humanitec token environment variable. So why is it telling me that? Well, because I have that set. This is literally the only part where I'm cheating a tiny little bit. Because I'm using a tool called direnv to pre-populate my environment with a few variables here, so that I do not need to do that by hand to save myself from typo land. And so you know that I'm not cheating a lot. I'm going to literally show you my NVRC file. So this is what's happening. This is my token. It's coming from the humctl login. I'm putting it into the Humanitec token variable, and I'm pre-populating Humanitec app, org, and env with strings I like. No magic. Whoops, that's the wrong one. Let's go over here. So humctl login, I've done that one. I don't need to do this one because I've got the env which has pre-populated this. Okay, next stop is for me to copy and paste this startup script. Yeah, sure, let's run it. So this is now going to run the 5-minute IDP container on top of my Docker daemon. And you should all be following along, right? You should all now start doing this. As you can see, that was really fast. No problem at all. One container running. All right, looks good, promising. Let's go. Okay, first step, 0 install. This is actually going to now, because my humctl is authenticated, this is now going to install all of the needed things inside of the organization I have chosen. And also the relevant stuff like my kind cluster. So first thing here, it's starting the kind cluster. As you can see, there's the 5-minute IP control plane coming in kind cluster. All right. Now Terraform run issues, which is going to configure the orchestrator. We do have a Terraform provider. And by virtue of that, I'm able to configure the orchestrator in this case with all of the stuff that I want via Terraform. And that is nice because Terraform also enables me to deploy the agent and also configure the agent and configure the configure the orchestrator at the same time. So both actually know each other. It's a secure tunnel, so both sides need to be prepped in the right way that they can authenticate and trust each other. All right, everything prepared, ready to deploy the application. I don't know, that was probably 2 minutes or so, right? So what does the tutorial demand from me as the next step? Deploy a demo workload. So let's do this. So what's happening here is that we are actually asking the orchestrator via HAMCTL once again to deploy a workload from a score file for us. What you've seen is the log of the deployment pipeline. And now we are synchron or periodically curling to see if we already have a result available. Why are we doing this? Well, the deployment needs to come alive. The Nginx ingress needs to be in place. The routing needs to work. That all needs a little bit of time. But as soon as I have seen enough curl commands fly past, I will be able to show you the demo application. All right, 502 instead of 503. This is good. Back to 503. This is better. We probably see one more 502, and after that, the application should be alive. HTTP error code magic. So why is this taking so long? Because my boss is not giving me a bigger notebook. All right. Nevertheless, we made it. Tells me my workload is now available here. And the interesting part is this port. So because I'm running a kind cluster inside of a Docker daemon or a Docker machine, which is connected to my host, I somehow need to expose that kind cluster through a port that I'm mapping. And this is the port that I'm mapping. So that means if I now open this up, it will tell me, sure enough, this is an application talking to a Postgres database on host Postgres modules hello, deployed with score. All right, that didn't take 5 minutes, right? That gives me a little bit of time. Actually, this clip running. Hey. Huh? So I can filter that for my a few aliases that I like to have around. So it actually looks a little bit nicer. All right, so this is what I have. And this allows me to also do a less, I think I need to do an APK at less because this is a minimal Alpine image. Okay, now I can actually use less. So I can less the score.yaml that has been used to actually create this deployment. I hope everybody is along to that step. This is the time where I try to open up the dreaded chat and see if I have anything in there, which looks like, no, it's not working. Okay, no, nothing. That's great. But you guys are alive, right? You're still alive and kicking. I hope so. So now I can see what has actually happened. I'm deploying a hello world workload here. That's the inside and the outside part of the container. This is the actual image I'm deploying. So it's the sample app of the score specification. I'm a little bit behind, but catching up. Don't worry, Jeremy. You have time to catch up. No worries. Because we are already in quite a bit, but we have 6.5 minutes for until we should reach the first break. Okay, so we have the connection string of the database here separated out into different variables that the application is picking up from the environment. And we are asking for the DNS name that we have actually got. And the reason for that is that there is a very specific configuration on how to acquire the DNS name so that we get this interesting DNS name up here. And as we have some time, we can actually look into that. Still not seeing that link to the 5-minute IDP tutorial. It's in the platform engineering or .org Slack channel called workshop-infrastructure-platform-engineering. I pasted it in there. I thought to myself I wouldn't do this, but I can probably paste it in here as well. Where is it? Yeah, that's what happens if you don't start your clipboard manager before you do that copy paste. Then you need to copy and paste again. There you go. Now it's in the chat as well. Links are okay as soon as I start pasting YAML configurations. That's probably not going to work so well. That's the reason why I'm going to put it into the Slack. So please, if you are not yet in the Slack, join it. If you are not yet in the channel, join it, because I will be copy pasting there. All right. So this is the stuff that got deployed. And oh, down here, DB type Postgres. This is what actually summoned the Postgres database, right? So that was that. And then the question is, where does all of the configuration come from? Well, if you want to find out, you can see there is a setup directory in here, and inside of there is some Terraform, and here is the setup, right? And if I, for example, want to take a look at what is happening with the ingress, then I can just take a look at the Terraform and can see that there's a Helm release happening with ingress and Nginx, right? And you can also see that here I'm exporting the node port 380. That's the reason why later on I can access my applications through that port. Okay, so what else do we have here? Yeah, let's not dive into that too much. It's just so you know where the stuff is. And you can go in there and have some fun later. All right. Use that a little bit. Yep. So 3 minutes till the first break. There's something coming in Slack. Okay, get pods. Fresh loop, back off. Exec format error. That's interesting. How did you get that one? Ah, let me have a wild guess. You are using Mac OS or Windows, and then you are running Docker. M3 Mac with Colima. Look, and you probably didn't configure your builder to actually build a Linux image or a multi OS image. And that actually leads to the fact that when you build the image for the application, the container image, it will actually be a Mac OS based image, and that cannot run inside of the Linux based Colima cluster. Right? So that is a little bit tricky. And I do not really know how to fix that quickly. Well, the problem there is literally Colima. If it would be Docker Desktop, and this is literally one of the only reasons. No, that's specific to Mac OS actually, not the M3 stuff. That's one of the reasons why I use the real Docker Desktop here. It allows me to use containerd here for pulling and storing images. Yeah, and if I enable that option here, all of my image builds will suddenly be multi-platform images. They will build a lot slower because of that, but in the end, I can build images locally, which are able to run inside of Linux-based Kubernetes clusters. Yeah, most people are not, hitting that problem quite so often because they are actually building all of their image either through a CI system or somewhere in the cloud, which usually ends up to be the right thing. Yeah, and then everything is compatible. But if you're on top of macOS and you're using Kubernetes locally, that is something that can really ruin your day. But on Windows, it's the same thing. Yeah. If you do not activate the right options or use the right tools, you will end up with incompatible images and runtimes. All right. Having said that, I have 30 seconds to go until we should have our first break, which means I should probably get back to slideshow mode and ta-da, give us our first break. Right, so I'm going to put in a 5-minute timer. I'm going to put that here very obviously, right? So feel free to have a break now for 5 minutes. I will stay around and see if I can help anyone who has problems. Okay. So let's see. All right. Just one problem. That is really promising. Ah, now that I remember. Hmm, Konrad, you could also take a look if you have, when you're using Colima, if you're starting a Kubernetes cluster with your environment. Actually not starting a Kubernetes cluster, but just starting the container component of Colima will probably do the trick as well. Yeah, because there might also be collisions between the standard Kubernetes cluster that Colima spawns if you specify to start a K8s cluster, which, yeah, and the kind cluster that we are summoning. That would be another option.
Clemens, there is one question in the chat. Could you please explain that Terraform part in summary?
The Terraform part. So from a summary perspective, we are using Terraform to configure everything that needs to be running. So we are basically starting a Kubernetes cluster, and then we have an empty Kubernetes cluster. And we have an orchestrator waiting in the cloud to be configured to use that Kubernetes cluster, right? And all of that configuration that needs to happen and all the things that need to be started, they are coming from the Terraform bit. So that agent that we talked about in the architecture view, that is being started through Terraform and is also being configured through Terraform to have a secret key. And then the public part of that key is propagated over through to the orchestrator so that they can mutually authenticate and authorize each other to talk with each other. And also, obviously, when we want to run that application, we want to create a Postgres database. Well, the orchestrator will not initially know how to do that correctly for your local notebook. Yeah. But in the Terraform bit, we are also configuring that part. So we are configuring the Kubernetes cluster that it hits that. We are configuring how to create a PostgreSQL database on top of your Kubernetes cluster. And because of that, when you run the score deploy, everything comes together. Yeah. That's what the Terraform is basically caring for. And the good part is, because it's Terraform, one destroy in the end will actually allow us to clean up our orchestrator tenant really quickly. So we also do not leave any crud behind. Speaking of the devil, it's now 10 seconds or so until the break is over. So I'm quickly going to stop that. I hope everybody comes back now. And I'm just going to hop over into the UI of the orchestrator so you have an idea of what happened because of the Terraform configuration. Well, you can see here is my application, 5-minute IDP CRBN. If I look at the URL here, that's also 5-minute IDP CRBN, right? Okay, and I have my development environment in here. I can see that was deployed by humctl score deploy. Sure enough, I have my hello world workload, which I showed you in the score file. Here's the Postgres database. I can see that's the host name of the thing. And if I want to, I can follow to this resource definition, which shows me, okay, this is being used, matching criteria. It needs to be this application ID, so no other application is going to get that configuration. And the configuration is literally using our template driver to create a stateful set and run a Postgres container right next to the service. That's how it clicks together. All right. So I hope everybody's back. You're still fresh and want to continue. So let's go. So infrastructure platform engineering. Now that's going to be a little bit more the theory part, right? Because as promised, we wanted to look into best practices quite a bit, hopefully. And to make that happen, we need a little bit of theory. So let's go. Let's start first with infrastructure platform engineering. What the funky exclamation mark is this about? So I've brought along my first 2 shots at that. So that is live from my scribbles a few years ago. So building a platform that helps to lifecycle infrastructure. That is a very naive explanation, right? But this is literally the meaning of infrastructure platform engineering. Build a platform that lifecycles infrastructure. Well, that's too obvious. There has to be something else, right? And there also is a second shot I did take a little bit later, which is building the integrations for that platform into an internal developer platform from the technical, the processual, and also the people view. Well, you might actually be better than me in the first thing. So building a platform that helps to lifecycle infrastructure. Let's not dabble in this, but rather take the road down the second lane. We will actually try to integrate such a platform or such a service into an internal developer platform, because that's the interesting part, right? How do I get my infrastructure out into the open? All right, so let's try to agree on an unconventional approach for that. Fixed it by throwing some money at it. I know the feeling, Konrad. Welcome to the club. All right, so let's agree on an unconventional approach, and that is silos are awesome. That sounds strange, right? When in DevOps, we've been fighting for quite some time to try to raise in those silo walls, right? To pull them down and integrate into cross-functional teams where you do not have the silos. But in fact, silos are awesome. If you have a department, for example, which is responsible to provide DB as a service, if it looks like this, if it is a silo that is well connected to the outside world, right? Look, all of these pipes here, right? There is stuff in that silo happening, but it's well connected to the outside world through a very defined API and a very defined abstraction, then silos are awesome. Yeah? Because essentially, I do not need or even want to know how those bases are created, maintained on day 2, to a very large degree how they are configured, right? What do I need to reason about if, for example, the iSCSI driver is of the right version that is actually providing the storage behind the storage class, behind the whatnot, behind the DB as a service. Um, if I am a developer and I want to solve a business problem, it doesn't make any sense. It is like that, yeah, if you have been around during the PlatformCon 24 edition, like the opening talk between Kelsey and Caspar, where they talked about that airport analogy, where Kelsey said, hey, you don't want to know, right? Silos are awesome. You actually do not want to be the guy who gets a cab, deposit it at his front door. You get out, you put your luggage into the cab, you drive the cab to the airport. Then you put the luggage out, you carry it to the airplane, put it in the hold. Then you climb in the airplane, get into the pilot seat. Then you fly the airplane to your destination. Then you fetch your luggage from the hold, yeah, and you put it into the next cab that you drive to your final destination, where you put your luggage into your hotel room after signing yourself in at the front desk. That's a horror scenario, right? You rather want to have a clear contract with somebody who facilitates all of that travel, who cares for the fact that your luggage is being conveniently carried for you and arriving at your destination. Silos are awesome if they are behind a clear contract. Yeah? That allows us to interact seamlessly. And this is literally what platforming is about. In essence, at the first look, a platform is a silo, which through a defined abstraction allows me to interact with it. And by that makes my life easier. I'm the guy who just tells the cab driver, get me to the airport, then drops off the luggage, lumps into the train right at the airport, right? Into the plane, and then gets flown around. All right. You need some more evidence that this is actually best practice in our industry? Take a look at a lot of things when it comes to architecture. Domain-driven design, bounded context. That's a silo, essentially, behind a very defined interface. And countless more examples that I could summon up, right? Team topologies. How the teams are actually being built, how they are configured, how they connect to each other, and how they don't. That's actually building up those communication paths along clear boundaries, aka silos. So it's literally what we affix to the term silo if it's positive or not, right? But thinking about this, what is the right API? So how I as an infrastructure platform engineer, how should I reason about an API? What is the right contract to have around? So first of all, it needs to be ubiquitous. Yeah, you should aim for the same API on the front end for the users, yeah, the end users, the developers, or whoever it is, might be data scientists, whatever, for all services. So if you have DB as a service, Kafka as a service, message broker as a service, and cache as a service, and each of them has a different API, it gets complicated. Yeah, so you should aim for an API that is ubiquitous. It should be interface agnostic. Users have workflows. I'm old-fashioned. I'm a terminal guy. I like to type stuff out on the keyboard. If you make me take that thing into my hand here, it needs to be a purpose that's behind that, or I'm annoyed. Yeah, I don't want to click around. But for sure, there are users which are different. And even I am different when I'm in an explorative session. If I want to quickly find out how the lay of the land is in an application that I don't know yet, or if I want to quickly find out where a problem might come from, then exploring through a UI is nice. Yeah, but you also want to have an API, you want to have a CLI, and you want to have a UI. They are equally important. And hyperscalers show us that this is the case. Right? This is the biggest secret source of hyperscalers. They provide these clear, ubiquitous interfaces to all of their services. Well, and then comes the true statement, be prepared for complex backend logic. Yeah? Because building your backend, your as a service solution into the uniform front end shouldn't be hard. So somehow you need to take the bridge from that more simple, abstracted, ubiquitous API to the complex logic that your backend probably needs to be driven. So that's the right API. So what is the secret sauce? Interfaces? No. It's all clear, right? It's a necessity. We do not need to talk about that. But that's not a deciding criterion. Everybody expects them to be around. Nobody thinks like, oh, it has an API, it has an interface. That's awesome. No, it's table stakes. Oops. Solving problems. If you have a setup like I've demonstrated, users can now have reduced cognitive load. Yeah, they do not need to interact with any complexities around infrastructure. Just 2 lines of code will get them a database. Yeah. And I don't even need to know the insides of the deployment system, Kubernetes. I don't need to know the insides of Postgres. I just get everything delivered at my front door. I can concentrate on my job instead of being shift lefted into trouble. Yeah. But that's also not the deciding factor. The deciding factor and the secret sauce is composability. So why is that the case? Building software means composing something from commodity building blocks. If you look at what developers are doing, that's literally what they are doing, right? They start a new project. First thing they do is they start looking for a framework. Next thing is they start looking for some open source components. Then they go to Stack Overflow. What can I copy and paste and not reinvent? Nowadays, Stack Overflow is dead. ChatGPT is the friend of choice, right? But the pattern is the same. I'm trying to compose as good as I can because odds are that if it is already out there and it has been discussed and has got quite some upvotes, that it is a battle-tested solution. Yeah, probably avoiding a lot of mistakes on my side that I would need to make and learn before I get to a piece of code that is as good as that. Yeah. So I'm taking that, I'm composing my software, and by that, I'm much more efficient than I could be if I would need to write all of that on my own. And the interesting thing is, if you transgress that to the infrastructure department, it means that composing your architecture from commodity building blocks, this is something that was only possible with hyperscalers because that is their business case. They have the money to invest into this cloud console, into that team that actually provides all of the glue that makes all of those services integrate. You're buying Postgres as a service from a hyperscaler. Well, buy observability from them as well. Push one button, and suddenly you get all of the telemetry of the Postgres inside of your observability solution. No need to think about the integration, right? It's been prepared for you in the background. And this is exactly the same, yeah, the same level of convenience that developers get from score files, right? That you see here in hyperscaler APIs and consoles. And that is literally the secret sauce. And that is what I&O departments most of the time are finding very hard to battle. All right, so let's take a look at the playing field. If that is the setting of the scene, what is the problem field? So usually we have 2 sides of the problem. We have developers on one side, right? They are missing self-service, a lot of cognitive load, everything is slow. They need to wait on other people because there's no self-service. Right? On the other side, infra and ops is waiting, not. They are executing over tickets and tickets and tickets that the guys over here are producing due to the missing self-service. That's a problem, right? Tickets mean insecure configurations, manual reviews, low standardization. The question is how to get out there. Usually, platform engineering is the answer. Why is that the case? Because you have the developer experience platform engineers, the DevOps people, who rely on automation to remedy the missing self-service. If something is automated to the point where you just need to push a button, well, you can actually have self-service. But that leads to the fact that the tickets on the one side are just replaced by concrete instances that now need to be maintained on day 2. That really doesn't help the infra and ops people. Yeah? So they need to have their champions as well, the infrastructure platform engineers. And their weapon of choice is standardization. And the reason for that is if you not only have a button to create a Postgres database, but if you take all of the configuration options away and let the platform create that from a very opinionated, standardized template for all of the compliancy, legal, and security requirements of your company, then suddenly the only choices the developer can take are few and minor changes to the configuration, like size. Is it publicly accessible or not if it is an S3 bucket, for example? Yeah, things like this. So no major changes. And that means you suddenly only have 2 or 3 templates per resource type from where you create all of your resources. And that means on the infrastructure side, you can start to employ fleet management tactics, which reduces the day 2 operations burden. That leads to the fact that time to market and cost goes down and innovation hopefully goes up because people are just able to deliver quicker and more. And marketing somehow impaled the managers on top of this pyramid. Don't ask me why. So if that is the case, how should a team look like for infrastructure platform engineering? Well, if you are doing the first thing from my definitions, right? You're providing a platform to create infrastructure as a service. You probably have that down better than I can explain already. Yeah. So let's again not go there. If you do an infrastructure platform, yeah, only if needed, which is binding more than one as a service into an infrastructure platform, mimic the internal developer platform model. There's great content out there, or just ask on platformengineering.org Slack. There are more than enough people who are happy to respond to questions like that. But the gist is you need to focus on the inside scope, automation and standardization. That is what you need inside of your infrastructure platform. Do not care about the outside interfaces so much because that is literally not needed for the infrastructure platform. If you think about this, like a multiplayer game, your infrastructure platform will be included or will be a deliverable, whatever, will deliver infrastructure through the internal developer platform because that's where all of the customers, so to speak, connect. And that means if there's an internal developer platform, send your API or interface responsibles into the platform team of the IDP as emissaries. Yeah, the seat at the table inside of the IDP round ensures that you're connected and aligned with the software development lifecycle. And that means you're prepping the IDP to be the vending machine for your infrastructure platform. And this is exactly how it should be, because it allows you to focus on the important part of caring for the infrastructure, existing in your silo, but have those well-connected pipes and that clearly defined interface, which is delivering into the IDP, and the IDP has its own interfaces to deliver towards the customers, because that's different concerns. Yeah, platforming is a multiplayer game, and one of the biggest learnings there is if you try to how to put that, to optimize your platforming attempt only towards one target group at the expense of another, you will fail. There's no way around it. So is the infrastructure platform only the infra and ops side of the full internal developer platform? No. Infrastructure platforms are the thing that is built over a lot of things that happen in the infrastructure department, depending on what you have there that you provide. One customer might be the IDP. but there are very different concerns. Yeah, the IDP is the vending machine for the infrastructure platform. It's the connection to the outside world, but that doesn't mean that, for example, that has a lot to do with day two operations. They are living inside of the I&O team, right? The DBAs who care for the database instances are sitting there, and they probably need some great tooling and automation as well to help with the maintenance of those databases and day two. That's a concern that is only belonging to the infrastructure platform and needs to be built out there. It has nothing to do with the IDP. Yeah. And I could go into different and more examples. Do not think that this is just deliverable mastermind relationship. It is a multiplayer game, right? And all of the players, they are on the same eye level. Cool. So demo case, let's get hands on keyboards and let's try to replace that nifty little Postgres database that we had with database as a service. How's that going to look like? So what we had was that. That's the model. And we're going to not change a lot in here. We're basically attaching our 5-minute IDP as the deployment target behind what the orchestrator is doing. And now we are going to get Cloud Native PG or CNPG into the picture. And CNPG is an example how DB as a service could be provided. It's an operator that is running on top of a Kubernetes cluster, which gives you which gives you Postgres clusters if you give it the right custom resource to say, I would like to have one, which essentially is something as a service encoded into this operator. This would be what the I&O team has built out to be as their engine to drive as a service delivery of databases. And the API in this case is defined as a custom resource definition on top of Kubernetes. So just using the extension points of the Kubernetes API to deliver its own API. Yeah. Actually, you could build out a DB as a service like this. No problem at all to do it like this. Yeah. You will probably not see that in your own company because most DB as a service attempts were started way before Kubernetes was even invented. And because of that, you're probably seeing different APIs. But we're taking this case to demonstrate how it could look like. Okay? So let's do this. Hands on keyboards once again. And I have got the page open already. So this is the documentation of CNPG. And I'm here inside of the quick start. And once again, I'm literally following the quick start tutorial. I do not have to do a lot more to demo how this is going to be. Yeah? Okay, set up the local Kubernetes playground. Done. Yeah, Minikube, I don't need that. Kind, I have that. Install CNPG. Please refer to the installation section. I don't need to because I've done that already. And I think I have prepared this. Let me quickly get back to safety. Yeah, inside of here, I need to have an IDE. What about Visual Studio Code? And inside of here, I have a CNPG shell script where I have got the stuff that I need now already prepared. So I don't need to fetch that from the tutorial. I can just put that in here for you. All right. So first thing, I need to kubectl apply. And the question is obviously, where do I do that? Well, on top of the terminal of my 5-minute IDP, because in here, my kubectl is actually already configured to hit my kind cluster. If I would do it from the outside, I would need to get that relationship right as well. Just for demo purposes, I'm going to do that here right now. Let's do a kind get clusters. And sure enough, because I've exposed that in the right way already during the setup, I will get my 5-minute IDP cluster here, which means I can do a kind which means I can do a kind get cube config -n 5min IDP. And that gives me the cube config, right? So I can see it. But what I actually want to do is I want to do almost the same. Yeah, Jesus. Almost the same. I want to export that. And now I've set my kubectl also on the outside to my kind cluster, which means I can do, I have an alias named k get nodes. Now I'm on the kind cluster here as well, right? But it's more easy if you just stay here on the terminal. I'm doing it from the outside. The reason for that is I want to be able to use tab completion. Okay, great. CNPG installed. Next step, check if running. That sounds easy, right? 1 out of 1, up and running. I don't even need to copy paste that for you guys. It's a no-brainer, right? And now I could actually add a PostgreSQL client to my 5-minute IDP and try to get something going there. But the question is, after installing CNPG, which was really, really easy, how do I actually use this? Right. So let's get back to the quick start tutorial here. It says deploy a Postgres cluster. That's what I want to do. Right. You need to have a cluster template. Okay, that looks like this. Let's see. Do I have that already? I sure do. I do have a PG cluster YAML. So that would be a Postgres cluster. Yeah, according to the custom resource definition of Cloud Native PG. Storage size is turned down a little bit. I don't want to waste so much of my space. It's named my cluster. It's the owner is Scott, and it's super secure by having its own secret. If I take a look at the secret, it's a basic out secret, and sure enough, it's Scott and Tiger. Hello, Oracle. That would actually create me a Kubernetes cluster if I would kubectl apply those two manifests. But I want that to happen automatically as soon as I deploy my application, right? That's the definition of how to utilize DB as a service in the right way. Okay, how do I make that happen? And this time, I've not done that for some time, run this webinar, so I'm not trying to create that thing live right now. I'm just going to take a look at the PG RESTDEF here, and I'm going to explain you guys what is happening. So this is an entity in the Humanitec sense, which means it is a resource definition for my orchestrator. Yeah, I'm going to rename this a little bit because actually, if I take a look at what's happening here, my application is named CRBN. Yeah, CRBN. Okay. Let's call that CRBN then. Yeah, I'm going to put that here, and also down here in the application ID, because that's the application ID. So I'm writing a resource definition for Postgres. It has this ID and this name. So far, so uninteresting. It's a definition for a Postgres cluster. And the driver type is the template driver. As I said during the beginning, the template driver allows me to write out arbitrary templates into the deployment stream, which might as well be custom resources. And that's what I'm doing here. I'm preparing a few variables to use later down the road. The name of the cluster is going to be my cluster, secret is my cluster secret, port, user, and password. I'll set them fixed here. And then I'll write out the secret YAML, but I'm not writing it out as you've seen it over here in a static way. But what I'm doing is I'm going to write it out using those replacers here, which also allows me to use base 64 encoding here for the username and the password. So it will work out because Kubernetes is expecting that to be base 64 encoded. Right, that's the secret YAML. That's the PG cluster YAML. And sure enough, I'm also writing out all of that stuff here. using those replacers. So why am I doing this? The answer lies in the outputs. Because if I look at the resource definition of what a Postgres looks like, there is an interface defined. And that interface expects these outputs: the host, the name, and the port, and the secrets, the username, and the password. If I have them, I can create a Postgres connection string in any programming language, right? And I now want to match exactly to this application. Yeah. If I have that, I'll be good. Now I only need to do one more thing. I need to check if I have a collision. So off to the resource management, and we're taking a look. We're having this one here, 5-min IDP CRBN Postgres. Okay, that's the same ID and name. Okay, so I will be overwriting this one. Yeah, it's also matching the same way. The configuration is also using the template driver, but it is literally writing out a stateful set. So it's creating a container. I'm not doing that. I'm just conveying through the API description that I have that I want to use my DB as a service. All right, let's get that going in two ways. First of all, I'm going to execute it, and then I'll copy paste the template into the chat so you can actually use this as well. Okay, easy as pie. humctl apply -f pg-rest dev.yaml. There we go. That's it. Now I applied this configuration to the orchestrator in the same way. I mean, humctl is named in memoriam of kubectl, and the interaction patterns are the same. I've applied this. Okay, cool. So 30 minutes are over. I need to be a little bit quicker so we can all get into our break as expected. If I go back here and refresh, I can see matching criteria, all of that is the same. But if I take a look at the configuration, I can see there's suddenly a secret YAML, right? I added the configuration, I can see it a little bit better. So the secret YAML is coming in here. Here goes the PG cluster YAML. So that is exactly what I wanted to have. Cool. Cancel. That is promising. So I'm going to put that into the chat for you guys. You can literally just put that into a file and humctl apply it. And then you can, by virtue of the magic of the simulated CI pipeline, just execute the one demo shell script again. Why? Because that's deploying the same thing again. And the rhythm of business for the orchestrator is the deployment, which means the next deployment leads to the fact that now all of the backing resources are resolved once again. And because of that, we are now creating a Postgres database, not as a container in the namespace, but we are supplying this custom resource, and we are creating a Postgres cluster through PG, CNPG. But we still connect it through the application because the interface of the Postgres is still the same. So I don't need to change my score file. I asked for a database which is confirming to this interface. And the CNPG one sure does. All right. Let's take a look at what's happening inside here. Still showing unhealthy. Does it say? Unhealthy, now healthy. Obviously, that did take a little bit longer because we created a complete Postgres cluster in the background, right? If I now open the application, it's still okay, but now it's hosting the database on my cluster read-write. That sounds promising. Let's see if I have been cheating. So kube control get all from the namespace, 5-min IDP CRBN development. So in here, I now have a service called my cluster read only and read write. I have a pod my cluster one, And I have a replica set for my application. One active, one of the last deploy to roll back quickly if I wanted to. All right, so let's do a kube control get all. And how are these things called? PG cluster, they are called cluster. Get all cluster and all namespaces. And sure enough, I can see in the namespace that I've been using there, the cluster named my cluster, which is in a healthy state, is actually there for 2 minutes and 9 seconds. So that did work out. And all out of a sudden, by just providing a different resource configuration and shaping that to call out to my infrastructure teams interface, I have redefined how developers will acquire their databases. And this is exactly how it should be. Why? For 2 reasons. First of all, that's the right level of convenience. That's the right level of composability. If I wanted to have another service, right, I could simply just add that to my score file, and I would get another one. I can compose my architecture freely from commodity components which are offered by the platform to me in the same way that the cloud provider would be offering me services. That's one thing. And on the other thing, other side, I have disconnected how the infrastructure is created through the resource definition, which means now the infrastructure and operations team is free to evolve their service. They can change that. And through the resource definition, I can define what version of the service, always the newest service version, whatever I want to actually use. Yeah, but I'm free to do evolution on the developer side and on the infrastructure side. And that's the power of a platform if employed correctly, that you're not only caring for start right, scaffolding, you're caring for keep right. You allow evolution in the background and have a robot in the middle that allows you to go back to the existing standards that need to be applied. Once again, probably keeping in focus security, compliancy, and legal, right? And all of your company's rule sets. All right, I've been going over a little bit. Nevertheless, let's do 5 minutes break. And then we go off to the next one. Let's go. Ta-da. Okay, let me see if there are any questions or any problems I can solve in the meantime. What if the IDP is not well established or different ones are used across the enterprise? Well, if it's not well established, you need to establish it. And funny enough, all you need to do is you need to make it good. If what you are offering is a step function better than what the people have right at the moment, and you show it to them, and you can show at least one credible team that is actually using your IDP, and they say it's a huge success, it's awesome, then all out of a sudden, all of the other developers want to have those shiny new toys as well. Yeah. But it literally needs to be a step function better than what the people are using right at the moment. That's the reason why you need to be so careful about selecting the right abstraction layers and levels, the right interfaces, so that the convenience factor is very, very high. We human beings are the race that invented the remote control, so we don't need to get up from the couch to push buttons on the TV set, right? If you offer the same level of convenience to a developer to acquire infrastructure, it will work, period. I've seen it work so many times. But you need to be careful around how you do that. Yeah. Um, that's why you try it now for the third time. All right, sounds good. Um, that's the agile methodology, right? Um, iterate. If you try something and it doesn't work, fail fast, do it differently. Um, what I can probably recommend you to do is to talk to some people who have a frame of reference on things that work, right? If I remember correctly, we are quite close together, right? We are just probably 20-minute drive with a car away from each other. So let me extend that offer one more time. Let's go and drink a coffee together and chat about what your problems are. Very specific. Yeah, then I can probably give you some very specific recommendations of what you can do. But it needs to wait a little bit. Lucky me, I'm going on a vacation on Friday. Yes. And I'll be gone for 3 weeks. But I will be reading most probably inside of platformengineering.org and still replying to people because that's what I like to do, even in my free time. So I'm probably doing this in my vacation as well, in the evenings at least. And then in 3 weeks from here, I'll be happy to go out and have that coffee with you. Right? If you're from further away and you still want to drink a coffee with me, no problem at all. There are two options. We can either one, make that a virtual coffee. Yeah. So always possible. Option two, you are playing the big spender and you care for travel and accommodations, and I come visit. All right. All jokes aside, I've literally done that. So, okay, 30 seconds to go. So I can probably stop the timer already so it doesn't scream into my ear. Put it back to 30 minutes for the last leg. And then we can slowly but surely kick it off again to the last round. Right. So last demo case, and let's jump right in. Observability, right? All of that service stuff is great, but there's literally a different thing that is probably equally important. It's a cross-cutting concern. And sometimes they get served as, as a capability as well. So observability as a service. How would that look like? So hands on keyboards again, you can follow along. So what are we doing now? We start on the same thing. Once again, 5-minute IDP, obviously. And now we're going to actually put OpenObserve into the picture. Why OpenObserve? No idea. It's a CNCF project. It is looking quite nice, a little bit like a Datadog clone. It just happened to pick my interest. So I wanted to try it out. And now it's part of the run here. If you fancy other tooling for observability, the pattern is the same. Okay, so how to do this? Let's get going before we wrap and go into questions and answers. All right, so we did the Postgres stuff. That was easy and fast. Let's do Open Observe. So first of all, I need to create a namespace, and I actually need to deploy the thing. Easy as pie by now, right? Let's do that. Paste that and deploy that. And obviously, while that is running on my side, give that to you as well. There you go. Right. So what I need to do now, I need to port forward that to my local machine to actually access this. No problem. Let's do this. Okay, port forward is running. Let's go to localhost at 5080 and see what's happening. Ha, here we go. Open or observe, up and running. And let's see if I was clever enough. No, I wasn't, obviously. I think, yeah, I think that was not a thing. Let's open, observe, standard, password. Let's find that. Password. Okay, complex pass hash 123 and root at example.com. Okay, that sounds sketchy enough to be correct. Root at example.com. And yeah, that worked. Ooh, good, I remembered that this was available there. So let me put that stuff into the chat as well. If you want to do the port forward, you can do it like this. And then the user is root at example.com, while the path is that one here. There you go. Okay, so here we go. Now that is actually giving me a lot already, right? I can see logs here, I can see metrics, I can see traces, all of the stuff I would expect to be around in Datadog. The only question is ingestion over here. It says, I need to get ingestion going. Lucky enough, there is also a description on how to make that happen. And I have actually put those together already, the parts that I can actually do. Which chat window are you using? I'm always using the Slack channel. Yeah, because inside of the Slack channel, I can be sure that you can copy paste that without any problems. All right, let's do fresh window. All right, we are in the right context. Kind export kubeconfig -n 5min IDP just to be sure. Get nodes. All right. Yes, now we can do this. So that's all the stuff that is actually in the tutorial section here. When creating OpenTelemetry operator, webhook failed to call webhook. Ah, dear me. Okay, it tries to call the webhook of the third manager, and that doesn't work because it's not yet there. Let's see if that works and we do not really apply this. So the only thing that we need to do now custom right? That's the stuff. No, that was definitely not the stuff I wanted to paste in here. 2 seconds. Let me quickly get rid of that and give you the right stuff. That's the right stuff. Put that as planned. Right, that looks better. Should be able to copy paste that without a problem. And now I need to go here to this cluster, right? Because I want to use the local cluster. Yeah, and all of that is actually only going to work if I use this definition here. Let me meditate. And let me get all from the open observe here. So we only have a service called open observe. And we are referring here to O2 open observe router. And that is tricky. All right. Now you need to understand that this is a Helm install, and it is actually installing O2C, and it is here depending on a Helm install that was called O2, which stands for Open Observe. And we need to fix that because we are using the non-high available deployment here, which means that those service names here, they are just different because we are not using the Helm release. Yeah. Okay, so let's see. Inside of there is nothing yet. Open observe, open telemetry operator system. Okay, inside of that we have all of that stuff. So that is up and running, and that is good. The operator controller manager is still creating. Okay. So inside of here, we only have the service open observe, which means we do not have the O2 dash part, and we do not have a router because this is not a high available thing. So we need to replace that by a single instance. But all of the secrets and authentications, they work as expected. Okay. Connection refused. Huh. And this is what I was fearing a little bit, because I think I need to redo the first installation. So why am I doing this? I think I actually misstepped during the original installation here. I think I need to apply this here first, and then we need to wait until Cert Manager is ready. And if I don't do that, all of the rest of the installations will be corrupted. So sorry for that. Open the selector. Let's delete that namespace as well. Do a final delete on the open telemetry. Open telemetry dash. Yeah, this one. Okay. So let's be a little bit more patient this time. And wait a moment. I think if I would have followed the tutorial here, so this is the quick start. I actually want to do a self-hosted installation on top of Docker. So No on stop of Kubernetes. So kubectl create namespace open observe, kubectl apply, this stateful set. I think I deleted those two as well, right? So I need to do that again. So then I need to re-engage my, no, it's still port forward. Okay, great. And then I need to browse to localhost 5080 and log in. Okay, so this is that part. Let's reload this. All right, here we go. Need to restart this. Now we're back in action. And then it will tell me, okay, install Cert Manager, wait for 2 minutes after installing Cert Manager for the webhook to be ready. Probably should have done that. Now update the Helm repo, install the Prometheus operator. So this is this part, and create a namespace. Okay. So let's do this again. And this time I don't have any errors in the end. And now it will work. So if you followed along too quickly or too closely, I'm very sorry. You have to do the same routine and delete that once and then go again. So I know I need to install the ingester, and I've set myself up to actually go here and then install the ingester. So I need to refer to this cluster here. So once again, copy and paste that over here and fix the part. All right. Just open observe.service.cluster.local. That looks good. Hope this tutorial will be updated to account for this. Gonna try it later. Yes, it's actually all in there, right? I'm just not following the right steps. Very sorry. The tutorial is correct. It's just me being a little bit clumsy. Sorry for that. Okay, now I should be able to do that. And this looks better. I'm not getting any errors. If now everything proceeds without errors, your cluster is now sending logs and metrics to OpenObserve. That sounds too good to be true, right? No, it isn't. Actually, that's what you need to do. I now go to the homepage. It says no data ingested yet. And the reason is because I'm not doing a lot of things. Now let's do a few reloads here. And let's go back over here. Reload here as well. It'll probably take a moment for that to work. Or if it doesn't work, I did one more problematic thing. Might be that I actually need to remove that port because obviously cluster internal, I do not need to go through the outside port. Good part here is then I can do helm dash namespace.
Clemens, there is suggestion from Sergey, as in your endpoint address would be incorrect. As in it has namespace, but not the service name line 3.
As the endpoint. Ah, you're right. And then obviously line 5, the endpoint needs to be like this as well. Okay, namespace, and then I need to just uninstall O2C. Okay. Okay, that was the part I was actually dreading. Okay. We refresh this here. Should actually be pretty fast. So probably I tricked myself and it needs to be 5080 here. The part is now that is pretty quick to fix. Whoop. Whoever tries to huddle me, please don't. Ah, there you go. Now it's working. So very sorry for that. Little ruckus here. It should actually be quite the same for you configuration-wise, apart from the authorization, obviously. So that's the reason why you better go here and then go to this cluster and copy that bit and adjust it in the same way. You just need to remove the O2 and router bits because it is a single service install. Also over here, keep the port and everything else, and then you'll be good when you copy and paste it from here. All right. It's interesting. Awesome. That means I can actually go to logs, or let's go to metrics first and say, hey, I can see, for example, Kate's component, pod name. Let's go to the logs and let's ingest a few more tries first. Okay, I can already see there are more streams coming in here. If I want to see more, I can now see all of those streams. And then I can take a look at some metrics like the, for example, the, I don't know, container memory available, right? I want to take a look here. I can see all of the ticks coming in, which tell me what memory is available, right? And this pretty much looks like Datadog. I guess that you guys are much more knowledgeable than I am in this kind of interfaces. I just wanted to show you that it is very easy to get that going. Now, to add the icing on top of the cake. So why is this actually working, right? There are two things. First of all, I cheated a tiny wee little bit, so I don't need to do redeployment. When I gave you that Postgres cluster definition, I actually set in here monitoring enable pod monitor. So that means the Postgres cluster will expose its metrics via a standard interface that OpenObserve will immediately pick up. That's the first thing. And the second thing is, what I now could do is I could actually go ahead and instrument my workload. So what is this here? This is a workload resource definition for my cluster, which means it uses template driver to match two workloads, like my application. I would just need to match it to the application once again, which has the ID of CRBN, like this. And now, if that gets deployed, it will match and it will update the spec. It will add the Datadog tags here, just because I can, and it will populate them from the context. But it will also add this here, instrumentation open telemetry IO inject Node.js. And that means that the OpenObserve collector should instrument this pod and inject the telemetry to monitor a Node.js application. And because I can inject that here from the sideline using the orchestrator, the developer doesn't need to do a thing. Right? So let's try this. Instrument.yaml. Once again, all I need to do is hamctl apply -f instrument.yaml. Entity bad request. Ah, dear me. Yes, that's an ID. It cannot have uppercase characters. Copy and paste. Oh, once again, fix the name and not the ID. Dear me. Here we go. All right, now we have it. Copy and paste that also over here so you guys can use it. Just save that into a YAML file, humctl apply -f file name, and you will have it as part of the configuration of your orchestrator. Sure enough, if I go to resource management, I can now find my instrument Node.js definition over here. Currently, it's not being used. Let's change that. Over to my 5-minute IDP. Once again, redeploy the application. I haven't changed a bit, right? I'm just executing the deployment script again. Which should lead to the fact failed. Could not find expected colon. What did I do? Come to JSON. Value set version deployment. Should I have escaped those here? Give me 2 seconds to find that out before you try yourself. I should have escaped them. Or now it says okay. 3 backslashes is probably a little bit much. I just need to drop the things to make this valid JSON. And it was running so well. And that the reason why this is not working is I wanted to give you guys a little bit extra because I didn't do that the last time around when I was actually running that workshop as part of Platform Con, and I wanted to give you a little bit extra. Last time I didn't have enough time to make that part work. And it seems like I somehow have created it in the wrong way so that it really doesn't work. Okay, a valid label must be an empty string or consist of alphanumeric characters, must start and end with an alphanumeric character. Okay. And the reason for that is the slash here, which is a problem. Probably. One last try. If it doesn't work, we'll cut it out. No. All right. I'm sorry, I've fucked up the syntax. And because of that, it doesn't work. So it should be literally like this. But there is a little bit of conversion happening here from JSON to YAML, hands and forth a few times. And I am lacking the right means to escape this. The only thing I could think of right now is a double escape here, which would turn this into the triple into a quadruple escape, which would be the right cadence. And if it really doesn't work, then it really doesn't work. And then we just do this, or I will probably post an update to the channel. Yeah, I will post an update to the channel as soon as I have it working. I'm sorry for that, guys. It would have been lovely to show you that because if that would work, you would actually be able to see a lot more in here, right? If I would be able to instrument the Node.js application, so these are streams here coming in. So 69 different streams of telemetry, and that would enhance, that would be yeah, also fed with metrics coming right from the application. So I could inspect the application logs in here. Would have loved to do that actually. All right, quick mode, right? So, oh, okay, so my 30 minutes are over. I'm not going to run a break right now because I've done too much around with the syntax problems. I'm very sorry for that. I hope you stay with me and stay for the wrap and then have probably some questions for me. All right, so let's wrap it up. What have we done today? Building an infrastructure platform versus building an infra platform engineering endeavor, an internal developer platform. So if you're building an infrastructure platform like this, then you're actually doing a lot of the things right already, right? You are creating your infrastructure platform silo, but the problem is the API, so to speak, right? You see, somebody needs to jump into his car and drive out into the desert, and then find the right outlet. Hopefully, park at the right outlet, press a button, and then the stuff will be dumped into his car. That's a lot of effort that somebody must take to actually get it right, right? And as we have seen, it is a lot more easy if you build your platform like this, yeah, or you build your silo like this. The right kind. Escaping is done with tilde, apparently. Yeah, exactly. Cool. I'll try that while you are having some questions for me, if I come around to it. So that's the right way to do it. You need to think about your API clearly. You need to think about how to connect your infrastructure platform to the world. Yeah. So that is left-hand side, building just an infrastructure platform. Right-hand side, infrastructure platform engineering. That's laying down the pipes, connecting your infrastructure platform to the world, and finding that balance. Infrastructure platform engineering literally puts data centers on eye level with hyperscalers, right? Because the internal developer platform is what is making the cloud provider API and the infrastructure API of your company, your I&O departments, which are providing services on the same level. They are both first-class citizens of the ecosystem system of your internal developer platform. And that's the great thing, right? So what is the promise of all of that? The promise is to have the right secret sauce. And if you remember, that was composability, right? And if you get that right, as I have shown with the OpenObserve part, for example, right? I didn't need to do anything more in there because I have created my Postgres service in a way that is already exposing the metrics in the right way. If I now order my telemetry, also no, my telemetry, my observability as well from the same platform, although this is not a cloud provider API at all, and nobody has done a lot of tinkering in the background, it is still coming together already, right? I just opened the observability and my metrics are already flowing in there from my Postgres databases. And I can observe that and I can have fun with that. So that is the right composability. That is what you want to have. The right experience when architects start building with their Lego blocks, right? That's the secret sauce. And that turns the IDP into the vending machine for your infrastructure components, which is basically the point where the coyote puts his ass into the sling and lights the rocket on his back, right? Because all out of a sudden, there's no difference in acquiring, let's say, a Postgres database from the cloud provider of your choice or from your data center. And the total cost of ownership from the data center will be a lot cheaper from the cloud provider. And then the tables suddenly have turned, right? So what does infrastructure platform engineering do for day two? That is an interesting question as well, right? So if you remember, automation, the ultimate goal is to provide full self-service. And as such, the automation is pushed to the possible. If you use the right platform components to make that happen, that's what you get. Standardization. Fully automated self-service interfaces allow for quick creation of many resources. Standardization is the balancing element, right? Remember, you had those resource definitions, and they are putting out the standards where your developers are acquiring their parts or pieces of the golden path from. And because that is highly standardized, you can employ fleet management tactics. Yeah. And that's what's actually allowing the maintenance, if you combine those value drivers, allow for the maintenance to be the least amount of maintenance possible. Yeah? Because the automation of service tasks, not per instance, but per standardized resource definition, so fleet management tactics, is allowing you to care for them all at once, which is highly efficient. That's what infrastructure platform engineering promises for day two as outcome if you stick to the best practices. So what have we touched today? The 5-minute IDP and the setup, so you can have your own playground really, really quickly. We did take a full circle around what infrastructure platform engineering actually is, how it feels to be in there. We have had 2 demo cases, DB as a service and almost complete observability. I will get the escape right, and then I will paste the updated resource definition into the Slack channel. So if you follow that along during the next days, you will definitely be able to run that example to full extent. Yeah, and then right now I just shrink wrapped a few conclusions for you, which leads us to the end. So if you have had all of that, the question naturally is, it's great to have that playground on top of my local machine where I can experience these things and I can think about the patterns and the implications. But how do I make that happen at scale? And the answer is, well, an internal developer platform. You can have that at scale quite quickly as well. So this is one of the reference architectures that Humanitec is offering. This is the AWS version. There are ones out there for all major cloud providers and also for OpenShift on-prem. If you need anything more specific, please just poke me. I have some on the back burner which are not yet as optimized as they need to be pushed out in the open. As I said, they are on GitHub, they are open source, they are completely terraformed. They will not start in 5 minutes, but probably in under an hour. Yeah, but they will actually consume cloud credits, so you need to put in a few bucks for that. But then you can have the same experience end to end on an actual IDP that you can iterate on and build out into your own minimum viable platform or your real internal development platform if you fancy. Those reference architectures are a great starting point. Right? This is a hybrid cloud version, also really easy to get. Yeah, you can see there's a cloud estate in AWS, and there's OpenShift on-prem. Obviously, you need to have a gateway if between the cloud estate where your IDP is running and the on-prem data center. Yeah, but these kind of setups really easy to get. As I said, you can get them basically out of the box. So that's where you can actually up level your experience and your playing field. Which takes me to the point where I can only say questions and hopefully answers. Right. If you have any questions for me, please shoot in the chat or in the Q&A tool. I hope Maria will read them out because I will be trying to get that escape with till the 1 done.
Clemens, as
Yeah.
always, making sure that everything works until the last fix. Guys, you can drop in your questions in the Q&A chat. For now, you just have flowers there, Clemens. Thank you so much for the workshop. This was awesome, and I'm looking forward to going through it again when we get the recording. So now you have this, I would say, goal to fix it and make sure that it works for everyone. Yay.
Yes.
Somebody is asking for the link to the workshop. Actually, you can find it here on YouTube. It's just like not being post-processed, yes, but if you want to save it, you will also receive it tomorrow in the email as well as slides and the link to the 5-minute IDP. And they're also asking about GitHub links. This is something that I would ask you to paste in, Clemens.
Yes, any second now. Let's see. Let me issue that and then GitHub links. Wait, GitHub links. GitHub links are GitHub links. GitHub.com / Oh, let's do this more easily. Let's go to humanitec.com /reference architectures because you have a link to the main one in there. And that will actually allow you to just click on fork repo, like for example, AWS, and then you have the very much longer link to the reference architecture with great explanations on what is contained, how to actually get it going. So a lot of stuff. As I said, it's all terraformed, and it's quite okay to use these. What you also have in here in the Humanitec architecture organization are so-called resource packs. Right? There's, for example, one for AWS. And if you want to have some infrastructure to actually play around with and you don't know how to create those first resource definitions because on top of a cloud provider, everything is a little bit more complicated, just go to the resource pack and you can see there's some primitives here where you can actually start building out real infrastructure from, or you can just go to the examples and run the scripts in there. For example, the basic Postgres example is not just giving you Postgres, it is giving you an RDS instance, the security group, which is actually able to connect that to a workload pod. Yeah. Or if you will fancy to use AWS RDS Aurora, then you have the same here. Right? Just run the example here, and you will have that available as resource definition on top of the orchestrator to try right away. All right. Any more questions? While I'll stumble around to escape.
And if you guys have any other questions, I don't know, later today or tomorrow, Clemens will be still around for one day. I know that he mentioned that he'll be on holidays, but you can easily just post it in that Slack channel that you're already at. So workshop infrastructure, platform engineering, and yeah, I'm sure if you, for example, go through the workshop on your own and have any questions, I'm sure that if you post it over there, you will get it answered. But with that, I would like to thank Clemens, first of all, to you. Thank you so much for driving it. Also to everyone who stayed till the end. And I see quite some people stayed till the end, so kudos to you guys. Hope it was insightful. You learned something today, especially debugging and things. Thank you so much for the suggestions from the audience as well. But once again, we're gonna send over the recording of this workshop and slides to everyone who joined us today, as well as I'll try to include the GitHub links and this 5-minute IDP that we went through today. And yeah, I'm sure that Tobias and Clemens have that coffee date, so you guys should schedule it someday.
Right.
Perfect.
Yes, that is going to happen. Just poke me on platformengineering.org Slack or on LinkedIn or shoot me a mail, however you like it. I'm around and we can make that happen.
Nice. And have a great vacation, Clemens. Hope you get some rest and all, I don't know, energetic and inspired to build more platforms. And yeah, with that, I think we can wrap it up and hope everyone has a great and safe end of the day. And yeah, once again, if you have any other questions, just pop them in Platform Engineering Slack. And cheers to you guys. Thank you, Clemens.
Also, thank you very much from my side. Thank you very much for hosting, Maria, once again. And also thank you very much to all of the people who endured me hobbling around on the keyboard, not getting YAML escaping right. I definitely need a vacation.
Yeah.
But as promised, I'll post the solution tonight in the Slack. I'll get it right.
Thank you
It
so much.
somehow helps if not 100 people are looking over your shoulders onto your keyboard.
Totally. Cool. Thank you.
All right. Have a wonderful evening.